right, so let's get started. Hello everyone. My name is Shayan Sanjideh, and I'm the Developer Relations Manager here at Injective Labs. Today, I'll be covering how to build in a multi-VM environment, specifically talking about one of the latest innovations to come out of Injective in EVM. So before we get into that, I want to do a quick overview on Injective. For those who may not know, Injective is a blockchain that is specifically built for finance. So what that means is that every single upgrade, integration, and partnership is always going to be geared towards creating the best network for DeFi developers. Everything that goes into Injective is really built with DeFi developers in mind. So what makes Injective different? What does that actually mean? Here are some core reasons or core modules that really separate Injective from other L1s. So first, Injective has incredibly fast transaction times with 25,000 transactions being processed almost every second. Those who build finance dApps know how important it is to have transactions being processed almost instantaneously, as this can make a huge difference with regards to user experience, total profits generated by your dApp. So it is important to really have as close of a Web 2 experience in your dApp as possible. Second, Injective can natively support a zero gas fee user experience, allowing developers to create dApps that abstract all the complexities of crypto away for users with zero fees. Injective also has a highly unique self-executing smart contract layer through its WASM-X module. What this means is that typically smart contracts need an external agent to invoke the contract and trigger the logic that is associated with it. But with Injective's implementation of COSM WASM, smart contracts on Injective can be triggered at each block on its own without the need of this external agent, further allowing developers to create advanced applications. And of course, the main key differentiating factor for Injective is our plug-and-play exchange infrastructure. Injective was one of the first, if not the very first, networks to have a fully decentralized order book infrastructure on-chain, which makes for trading and finance dApps to create products that are more seamless, efficient, and familiar for DeFi users. It also allows for some unique features such as frequent batch auctioning and shared liquidity to occur. So in a nutshell, you can think of Injective as being the chain to power finance applications at its core. Like I said, one of the biggest things we have is this shared order book that everybody can tap into with our a plug-and-play order book that you can build finance dApps on top, a shared liquidity layer that market makers are already market making on, and really you have everything it takes for you to just take what you need with regards to developing a dApp and using that to just quickly build and quickly iterate. And as mentioned earlier, FBA, or frequent batch auctions, with regards to our frequent batch auctioning model, this solves some of the biggest capital efficiencies that users see on centralized exchanges or AMMs. The FBA model helps to eliminate issues like front running by batching orders over a discrete time period and crossing orders by the priority of market orders, unfilled limit orders, and limit orders from the most recent auction interval. All orders are not published to the order book until the interval ends, which eliminates the possibility of front running and negative spreads. And of course, being able to match all orders in one shot allows for massive scalability improvements that enables Injective's parallelized order processing, contributing to a total of a theoretical 25,000 TPS. And Injective also has, as I mentioned earlier, this shared liquidity model, which means that all dApps can tap into this shared liquidity that is available on-chain, eliminating the need for smaller dApps or protocols to find and source their own market makers. Market makers on Injective trading markets that are being utilized across all sorts of different dApps on Injective. And all of these things are just some of the features that make Injective tailor-made for DeFi developers. But Injective is not just different on the chain level. It is also built differently so that it's easier for DeFi developers to build a Web3 financial application. What we like to say is that Injective has plug-and-play modules that make it easier for developers to quickly utilize and launch their applications. So as I was saying earlier, these are just some of the modules that are available for developers to utilize. So of course, one of the biggest ones that I was talking about earlier was the order book module and the smart contract module that allowed developers to create financial dApps as well as their own unique applications. But Injective also has binary options, a binary options module, Oracle module, auction, and bridging module that are readily available to use for developers looking to build on Injective. So developers don't need to source their own partnerships. You don't need to find your own oracles. You don't need to build your own binary options module from the ground up. You can, if you have an idea, you can easily tap into one of Injective's modules to make that entire process of creating a dApp just that much easier. So we like to essentially ease the developer experience as much as possible. So you as a developer can focus on creating more novel and interesting dApps and leave all the handiwork in the back end for us to handle. The bridging module, I should add, is also is a highly useful feature for dApp developers because Injective is one of, if probably the most highly interoperable networks within Web3. So not only does it support native IBC, but it also has its own Peggy bridge, bridging Injective to Ethereum. And we have also integrated Wormhole, which opens the Injective network to a multitude of different L1s and L2s, such as Solana, Aptos, Polygon, and much more. But today, I'm here to talk about Injective's Electro chains, which takes it a step further when it comes to interoperability and scalability than just creating different bridging solutions. Injective's Electro chains fosters flexibility and compatibility, empowering developers to deploy dApps across various blockchain systems seamlessly. The first of these Electro chains are in EVM and in SVM, the different rollup environments for Ethereum and Solana respectively. These VM environments accommodate different virtual machines, each tailored to execute smart contracts written in different programming languages or adhering to different execution models. This setup facilitates interoperability by allowing developers to leverage the strengths of different VMs while ensuring compatibility with existing smart contract standards and infrastructure. Injective's in-EVM environment is also inherently different from other EVM chains because it integrates Ethereum into the IBC ecosystem, representing a significant advancement in holistic composability. And today, we'll cover how to deploy an Ethereum dApp on an EVM. So getting started with NEVM is very easy, and deploying on NEVM is just the same as any other EVM compatible chain. So it should be relatively intuitive. On top of this, there are a lot of unique tools and integrations exclusively on NEVM that you as a developer can leverage to interoperate seamlessly with Injective as well as other chains like Ethereum and Solana. In this workshop, I'll go through 2 projects uniquely integrated with NEVM that gives you as a developer leverage to, on day one, integrate with and interoperate with Injective and other prominent blockchains. So first, let's cover Hyperlane. So Hyperlane isn't just a bridge, but rather it's a universal and permissionless interoperability layer built for the module blockchain stack, perfect for rollups like in EVM and in SVM. With Hyperlane on Injective's in EVM, you can build interchain applications that abstract the complexities of the multi-chain world away from users. If you want to build a Solidity dApp that allows users to place orders directly on Injective's exchange apps, Hyperlane can make that happen seamlessly. So here are some of the interesting features of Hyperlane. So the first of these are contracts. Hyperlane exposes on-chain contracts that allow applications to send and receive messages. The second of these are agents. Agents in the network operate the protocol by adding security and relaying messages across chains. And finally, applications. and that's everyone here. You can use the protocol to send and receive messages between different chains secured by Hyperlane. So here's how you can interoperate between an EVM with Injective or other chains using Hyperlane. So first, you would create a message object containing the destination chain, recipient address, and message body. Second, you would deposit the required fees to cover the cost of sending the message. And third, you'd call the dispatch function on the Hyperlane contract, passing the message object as an argument. And if you're trying to receive messages or events happening on Injective or other chains, you'd first monitor the message received event on the Hyperlane contract. Then second, process the message. When the event is fired, process the message by extracting the sender, recipient, and message body. And if you have any more questions, we'll be releasing more docs, so feel free to reach out to me after this or the Hyperlane team to get started if you want to build on top of this. So with Injective's deep integration with various prominent blockchains and the liquidity the ecosystem has gathered over time, you can easily deploy a dApp on any VM that accesses liquidity and users from all over the multi-chain world by connecting to simply just Injective. Okay, and another great protocol deployed on any VM is Layer 0. For those who are building multi-chain dApps, Layer 0 allows you to build omni-chain interoperable applications using its open source immutable messaging protocol. And one of the coolest parts is that introduce a new type of app to the dApp ecosystem on EVM, OApps. So what are OApps? OApps stand for omni-chain applications, a type of decentralized application that operates across multiple blockchains. In the context of in EVM, OApps can integrate not just within Injective's ecosystem, but across all connected networks, leveraging Layer 0's infrastructure. To become an OApp, you need to integrate with Layer 0's omni-chain interface contract, OIC, in EVM. This is a core smart contract that defines the logic for cross-chain interactions. On EVM, you'll also find the corresponding Layer 0 endpoints, which are crucial components that facilitate communication between different blockchains. After the initial integration steps, you can build your own custom user application, which takes care of the user-facing component of the OApp that interacts with the OIC. What's cool about these OApps is that they have horizontal composability. So OApps LZ Compose enables this by allowing for external cross-chain calls to and from any EVM to be containerized in a new message packet and ensure that the receipt logic is separated from the external call itself. There are also further extensions purpose-built for NFT ecosystems called OFT OAP extension, which facilitates cross-chain NFT for those of you interested in building an NFT project. And finally, NEVM. To get started as an NEVM developer, you can find oappsender.soul or oappreceiver.soul deployed on NEVM from the Layer 0 docs soon. And again, feel free to reach out to me after this if you have any questions regarding finding this. There's an omni-chain network interface, OIC, specific to NEVM's ecosystem that you can implement to get started with your first OApp on day one. And then afterwards, you'll be able to leverage NEVM's Layer 0 endpoint for secure and efficient cross-chain messaging powered by Layer 0. And if you have any more questions on NEVM, or if you are interested in building on NEVM for this hackathon, please feel free to scan this QR code or just simply go to docs.nevm.com and you'll be able to see the documentation that we have for NEVM, as well as being able to seek additional information with regards to developing on NEVM. And for this hackathon, we have a Telegram group chat available for you, the hacker, specifically. So if you have any questions with regards to, if you're interested, firstly, in developing on NEVM for the ETH Seoul hackathon, feel free to join this group, talk to other builders, ask questions. I'll be there to answer. I'll loop in other people from the Injective Labs team if needed to help answer questions. So feel free to use this group for finding other hackers within this hackathon specifically. And then also feel free to join our more general Telegram builder group. So this is going to be like the Telegram builder group for the wider Injective audience. If you're interested in seeing the developer ecosystem on Injective, interacting with developers and builders within the greater ecosystem, potentially taking your hack the next step further, seeing what projects are deployed on Injective, wanting to collaborate with them, I would definitely recommend joining this as well. And thank you so much for listening. You can follow us on Twitter @Injective. Look at our website, injective.com. You'll be able to see our documentation for not just in EVM, but the layer 1 itself. And I forgot to mention this in the beginning, but yes, we are hosting a track for this hackathon for developing on in EVM. And if you're interested, please see me after this, and I'll be more than happy to chat. And yeah. Thank you so much again for listening, everybody.